The sun, a blazing sphere in the sky. To the naked eye, it looks calm, constant, almost simple. A reliable lantern in the dark of space. But beneath that glowing surface lies a reality governed not just by heat and gravity, but by the strange and counterintuitive laws of quantum mechanics. What we see is only the photosphere, the outer skin. It is the final boundary before light breaks free. But this light is not new. Light escaping from this layer has taken thousands, even millions of years to reach it from the core. Every photon you see is ancient. The sun is not just a fireball. It is a quantum engine. To understand the sun, we must look where light begins, the core. Here, the pressure is 260 billion times that of Earth's atmosphere. You'd think this would be enough to smash atoms together and create energy. But classical physics says no. The protons in the sun's core are all positively charged. Like the same poles of two magnets, they repel each other with a force called the Coulomb barrier. At the temperatures found in the sun, these protons shouldn't have enough energy to touch. By all the rules of the macroscopic world, the sun should never have turned on. It should be a cold, dark ball of hydrogen. So, how does the sun shine? It relies on a quantum miracle called quantum tunneling. In the quantum realm, a particle isn't just a solid, it's a wave of probability. Even if a proton doesn't have the energy to climb over the energy barrier, there is a tiny, non-zero chance it can simply exist on the other side. It tunnels through the impossible. In the sun's core, this happens trillions of times every second. Protons defy classical logic to fuse, releasing the energy that eventually becomes the light on your skin. Without this quantum loophole, life as we know it wouldn't exist. Once a photon is born in that quantum forge, its journey has only just begun. It doesn't fly straight out. The sun is so dense that the photon can only travel a fraction of a millimeter before slamming into another particle. It gets absorbed, re-emitted, and scattered in a random walk. This journey through the radiative zone can take over 100,000 years. The light hitting your eyes right now began its journey when mammoths still roamed the Earth. It has been filtered and processed by the sun's internal plasma, a state of matter where electrons are stripped from their atoms, creating a soup of charged particles. By the time that ancient light reaches the photosphere and finally leaps into the vacuum of space, it has transformed from a gamma ray into the visible spectrum we see. It takes only 8 minutes to cross the void to Earth, but it carries the history of a million-year struggle against gravity and the incredible success of quantum probability. Next time you look at a sunrise, remember, you aren't just looking at heat. You are witnessing a quantum engine, operating on the edge of the impossible, powering our world one tunneled proton at a time.